Hello viewers, welcome to my channel. Our topic for today is word problem on fraction. So in today's class, we are going to be applying fraction to real life experiences. So the examples we have on the screen are what happens in our day-to-day activities. Let's solve the following question we have on the screen. We'll be starting with number 1. It says, after spending 2/5 of her money on food and 1/6 on cosmetic, a woman was left with 1,300. How much money did she have originally? So the question here, we have to look for the amount of money she had originally. So for we to do that, we have to break this word problem into mathematical expression. Now let's start with this, her money. We don't know the actual amount, and that is what we are looking for. So the first thing we're going to do is to denote a letter to her money. Her money should be, let's give it letter X. So after spending 2/5 of her money on food, she spent 2/5 of her money. So 2/5 of X is going to give us 2x over 5. Remember, of means times. So the next is 1/6 on cosmetic. So on cosmetic, she spent 1/6 of her money, which is the same as x over 6, because 1/6 times x is x over 6. So a woman was left with 1,300. So the money she had left is 1,300. Now, how much money did she have originally? So with the whole information we've gotten out from the question, let's have original money should be equal to the expenses plus money left. So this way, let's relate this to real life happening. Let's assume I actually went to the market to get some things, and then I had some money left after buying everything I needed to get. So when I got home and I actually want to calculate to know the actual amount of money I took to the market, what I'm going to do is I'm going to calculate the money spent on everything I got in the market plus the balance I had when I got home. That will give me the original money. So which is exactly the expression we have here, which is original money should be equal to the expenses plus the money left. So now the original money, that is our money, our actual money here is X equal to the expenses. On food, she spent 2x over 5 plus on cosmetics, she spent x over 6 plus the money left, which is 1,300. So with this expression, we now have our question in fraction. So here we have on the right hand side 2x over 5 plus x over 6 plus 1,300. So what we're going to do here, we're going to make this fraction also. Then I could actually erase the naira because for now we will not be needing it. Then we look for the LCM. The LCM of 5 and 6 is 30. The reason we are looking for the LCM is because the fraction is not equivalent. We need to know the LCM to be able to convert this fraction to an equivalent fraction so they all have the same denominator. So now we have x equal to the LCM, which is 30. So 30 divided by 5, we have 6. 6 times 2 gives us 12x plus 30 divided by 6 is 5. 5 times x, we have 5x plus 30 divided by 1 is 30. 30 times 1,300, we have 39,000. So we collect like them, we are going to add this algebra together. So we have x equal to 12x plus 5x gives us 17x plus 39,000 all over 30. So for we to solve this question further, we are going to cross multiply. So 30 times x gives us 30x equal to 17x plus 39,000. Now we're going to collect like this. Algebra to algebra, so we have the number standing on its own. So 30x, when plus 17x crosses equation sign, it turns to minus 17x equal to 39,000. 30x minus 17x gives us 13x equal to 39,000. So to get the value of x, we have to divide both sides by the coefficient of x, which is 13. So 13 cancel 13, we have x equal to 39,000 divided by 13 gives us 3,000. So if x is equal to her money, so therefore her actual money or her original money is equals to 3,000 naira. This is the answer for number 1. Now let's move to number 2. So for number 2, we have 3/4 of the girls in SS1 play basketball and 4/7 play volleyball. Every girl play at least one of these games. If 27 girls play both games, how many girls are there in the class? So just like we did with question number 1, the first thing we're going to do here is to break down this question and bring out the important information. So we have 3/4 of the girls. So the girls in SS1. We don't know the actual number of these girls. So we can possibly break this down as the girls in SS1 should be equal to, let's use a letter to represent this also. We could possibly use Y. So the next thing is 3/4 of the girls in SS1 play basketball. So the number of girls that plays basketball is 3/4 of the girls in SS1, which is of Y. So 3/4 of Y is the same as 3y/4. And the next is 4/7 play volleyball. So for volleyball, the number of girls that play volleyball is 4/7 of the girls in SS1. So of Y, which is 4y/7. Every girl play at least one of these games. What this means is no one was idle. Every girl in that class played at least one of these games. So it could be a particular girl could be playing 2 games or one of the games. So there's no way you can meet a girl in that class that is not playing either basketball or volleyball. That's the meaning of every girl plays at least one of these games. So if 27 girls play both games, so both games, that's both volleyball and basketball, 27 girls played it. 27 girls played both games. So how many girls are there in the class? So what we are looking for is the total number of girls in SS1, which is Y. So the next thing we're going to do is, with this information we actually brought out, we're going to put them into mathematical expression. So it should be girls in SS1 equal to those who play basketball plus those who played volleyball minus those who played both. So explaining this expression I have here, it's saying girls in SS1 is equal to those that played basketball plus those that played volleyball minus those that played both games. The reason why we are minusing those that played both games is because those that played both games is actually in the expression of those that played basketball plus those that played volleyball. They are here. Those that played basketball plus those that played volleyball, those that played both games actually exist in this two. So we're going to minus it so that when we remove the number of those that played both games, we'll be able to get the total number of girls in SS1, because every girl in SS1 either played basketball or volleyball. So this is girls in SS1 is Y equal to those that played basketball, we have 3y/4 plus those that played volleyball, we have 4y/7 minus those that played both games, we have 27. So just like we are looking at this, 27 is a whole number, we have to make this a fraction. And the next thing we're going to do is to look for the LCM because we have unlike fractions. So the LCM of 4, 7, and 1 is 28. Now we have the LCM, we're going to make this the new denominator and convert every fraction there to an equivalent fraction. So working with this LCM, we have y equal to, on the right hand side, we'll have a new denominator as 28. 28 divided by 4, we'll have 7. 7 times 3 gives us 21y. Plus 28 divided by 7 will have 4. 4 times 4y gives us 16y. Minus 28 divided by 1 is 28. 28 times 27 gives us 756. So we're going to add this together. These are like terms. So y equal to 21y plus 16y gives us 37y minus 756 all over 28. So because of this fraction on the right hand side, we're going to cross multiply. So 28 times y gives us 28y equals to 37y minus 756. So these two are like term. We're going to collect like term. Now 28y minus 37y equal to minus 756. So 28y minus 37y gives us minus 9y equal to minus 756. So the next thing we're going to do is to divide through by minus 9. When we divide through by minus 9, we'll be able to get the value of y. So y is equal to minus 756 divided by minus 9 gives us 84. So if y is equal to the girls in SS1, so therefore the number of girls in SS1 class are 84 girls. So let's move to question number 3. So for question number 3, we have a man made a will in which he left 4/9 of his money to his wife and 2/5 of the remainder to his eldest child. The rest was to be shared equally among his 4 younger children. If each of the children received 108,000, what was his wife's share? So for this question, we are looking for the wife's share, not the original money that was shared among them. So let's break this information down bit by bit. A man made a will in which, okay, let's take note of the man's money. How much does he have at first? So let's say the man's money is equals to, let's denote this as letter M, M for money. So the man's money is M. Now we'll have to look at the wife's share. The wife's share is 4/9 of his money. 4/9 of M, which gives us 4m/9. So the next thing here is 2/5 of the remainder to the eldest child. Before we can get the eldest child share, we have to take note of this word here, remainder. Of the remainder. That means after giving the wife her share, the remaining money, the eldest child has 2/5. Now, how do we get the remainder? In fraction. Whenever we want to get the remaining parts of a whole, that whole represents 1. So 1 minus the fraction of the wife's share will give us the remaining fraction for the children. So the children's share is equal to 1 minus wife's share of the money. That is wife's share of the man's money, which is equal to 1 minus, let's put this in brackets please, 1 minus the wife's share. The wife's share is 4/9 of the man's money. The man's money is what? We represented that as M. So for we to get 1 minus 4/9, the LCM here is 9. Now 9 all over 1. 9 divided by 1 is 9 times 1. We'll have 9 minus 9 divided by 9 gives us 1. 1 times 4 will have 4. remember to put that in bracket, of m. So 9 minus 4 gives us 5 over 9 of m. So therefore, the children's share is 5m over 9. Now, for we to get the eldest child share, it becomes 2 over 5 of the remainder. Now we know the remainder. This is the remainder. Let's not forget that. This is the remainder. So 2 over 5 of the remainder, which is of 5m over 9. So this is 2 over 5 times 5m over 9 equal to 5 here 1, 5 here 1. So we are left with 2 times m, which is 2m all over 9. So the eldest child share in fraction is 2m over 9. The rest was to be shared equally among his 4 younger children if each of the younger children received 108,000. So each of the younger children received 108,000. Remember, the younger children are 4 in number, so 4 of them gives us 4 of each of their money, so which is 4 times each of their money, which is 108,000, gives us 432,000. So now we're going to express this whole information in mathematical expression. So which is the man's money, that's his actual money, should be equal to the wife's share plus the eldest son's share plus the 4 younger children's share. Good. So you can actually relate this to real life experience, whereby the man maybe is dead or not yet dead, but actually wrote a will. So if the wife collects her share, the eldest son have his, the 4 younger children have his. So how do we calculate the actual man's money? But take note, we're not looking for the man's money, we're looking for the wife's share. But before we can get the wife's share, we actually need to know the man's original money he left behind. So for we to get that, we're going to add the wife's share plus the eldest son's share plus the 4 younger children. After we add them together, we'll be able to get the original money that was shared among this family. So remember, the man's money was represented as m equals to the wife's share gives us 4m over 9 plus the eldest son will have 2m over 9 plus the 4 younger children will have 432,000. So we're going to make this a fraction, so it's going to look like others on the right hand side, and look for the LCM. So the LCM of 9, 9 and 1 is 9. So m equal to, we now have a new denominator, which is the LCM, 9. 9 divided by 9 is 1. 1 times 4m, we have 4m, plus 9 divided by 9 is 1. 1 times 2m gives us 2m, plus 9 divided by 1 is 9. 9 times 432,000 gives us 3,888,000. Now, these are like terms, 4m plus 2m, so m equal to 6m plus 3,888,000 all over 9. So the next thing we're going to do, we are going to cross multiply so that we're going to eliminate this fraction and put it in a linear expression. So 9 times m gives us 9m equal to 6m plus 3,888,000. So we're going to collect like them, taking 6m to the left hand side. So we'll have 9m. When 6m crosses equation sign, we'll have minus 6m equal to 3,888,000. So 9m minus 6m gives us 3m equal to 3,888,000. So for we to get the value of m, we have to divide through by the coefficient of m, which is 3. So divide both sides by 3 our m is equal to 1,296,000. So remember, m belongs to the man's money. So we can say that the man's money is equal to 1,296,000 in naira. 1,296,000. So remember the question said we should look for the wife's share. Thus, the wife's share is equal to 4m over 9. Now we've gotten the value of m, so this is 4 over 9 times m is 1,296,000. So let's put this as over 1. So we're going to multiply 4 times 1,296,000 gives us 5,184,000. All over, we'll have 9 times 1, which is 9. So when we divide this together, 5,184,000 divided by 9 gives us 576,000. So therefore, you agree with me that the woman's share or the wife's share is 576,000. So this is the answer for question number 3, and this is all for today. I believe with this video, I've been able to help those that have difficulties solving word problem on fraction. Now you've been able to know how to translate word problem into mathematical expression and break it down into simple terms, so you'll be able to tackle them well. If you have any question concerning fraction, comparing fractions, simplification of fraction, and word problem on fraction, drop it on the comment section. I will definitely attend to them. Thank you very much for joining me in today's class. See you in my next class. Bye.